presenter here is Dr. Noel Schulz. She is not only the wonderful wife of our new president, but also a very distinguished professor in electrical and, and computer engineering. I always forget the computer part. Electrical and computer engineering, and is quite fluent in power systems and sustainable energy. So she's here to talk to us about her interests regarding sustainability.
Thank you. Thanks, Ben. Let me put my water over here. I'm used to a little more humidity than you guys have up here, so I have to have water with me. That's why you saw Kirk get choked up this morning. It wasn't necessarily a topic he was getting choked up on. It's just we're still getting used to the less humidity. Oops. So unfortunately, women's outfits are not designed with pockets the way some of the men's are for these. All right, so what I like to do is talk to you a little bit. This is my first opportunity to have a presentation outside of my department, so no pressure or anything in my new opportunities here at K-State. And I'm actually not officially here yet. I'm in the process of moving. I'll be here August 9th officially. We have a son who will be a freshman at Mississippi State this fall in computer science, so I'm down in Mississippi finishing up the transactions and activities down there, and then move him in on August 8th, and then drive up here on August 8th and 9th. So I appreciate this opportunity. My husband was talking to Ben about this conference, and Ben asked him to, if he would be the start out speaking, and then said, oh, my wife's in power systems, why don't you see if she'll speak? So nothing like help from your husband with things like that. So a little bit about what I'm going to talk about today, a little bit about my background, why am I up here as far as what I've done. Kirk's resume is on the web, and you probably know a lot more about him. But I want to tell you a little bit about some of my background and my interests in this area, and really the opportunity to move to K-State is giving me to get more engaged in these activities. Then a little bit about changing the conversation in the U.S. based on some experiences I've had. And I'm going to kind of interweave the technical challenges to make sustainability possible as we balance reliability and sustainability, and then opportunities for K-State. And for those of you here this morning, these will piggyback a little bit on some of what you heard Kirk say. So because he had his presentation done first, I knew about it while I was working on this one last night. So I want to give you a little bit of background about me, and so you know where I'm coming from. I am electrical and computer engineering. We met at Virginia Tech, and that's where I got my bachelor's and master's degree. And then while Kirk, we were one of those two-body problems, so while Kirk was finishing up his PhD, I was an instructor. And then we moved, and somewhere the University of North Dakota logo, oh, it's up here where, this is normally has Kirk up there, but I didn't feel you needed him up there today, so. The University of North Dakota, I was an instructor there. After working at Virginia Tech a little while, I went back and got my PhD at Minnesota. And then we had an opportunity, we were at Michigan Tech, so we are used to snow and we're used to cold between these. And then we've been at Mississippi State since 2001, before becoming cats. We turned from dogs to cats this summer, so. But a little bit about my background and what are some things that have helped me become interested related to sustainability, renewables, and distributed generation. A couple of purple balloons here. And the first one is I had an opportunity to spend the whole summer working for Northern States Power Company in Minneapolis. And that really helped me see from the side of the electric utility some of the technical challenges and opportunities that are there as we saw emerging technologies, distributed generation, all those kinds of things. I talk with my hands, so sorry about that. So that really gave me an insight from being on the utility side and some of that. I've had a chance through my career to do some activities, and I'll talk to you about those. But what's probably been the bookend of that is I had an opportunity to spend last fall semester 4 months in Wales on sabbatical. So that I could, I wanted to look more into renewables, into some of the different activities, and really this was an opportunity for me to go around the UK and the EU and learn more about what's happening over there. So those are kind of some of the activities that gave me some of the background. Some of my teaching interests and different things related to, a lot of the work I do is similar to Neil Paulo, one of your experts here in electrical and computer engineering, is in computer applications and understanding system level activities, modeling and simulation and some of those type of activities. Some of my teaching interests in general electrical engineering. And I also have a lot of interest on engineering in the global community, as well as women and minority activities and faculty development type of things. So just a little bit about some of my interests. So as far as some of the things I've had an opportunity to interact and work with recently, I've been working on a large project with the Department of Defense related to the all-electric ship, which has a lot of distributed generation type activities. Obviously, you're not putting a lot of windmills on the top of a Navy ship or even solar cells because of heat issues, but there are some system level activities that are similar to some of what we talk about related to distributed resources. Also working on a Department of Energy project, and we'll talk about that a little bit more. These are some of the utilities and industry that I've had a chance to work with, and these were all the schools I had a chance to visit and see some of their research projects related to renewables, distributed generation, and sustainability type projects. And that was really helpful for me related to the topic we're talking about today. So a little bit about some of my personal experience. I had an opportunity while in Mississippi, at Mississippi State, to do some work on, we have some Indian lands in the middle of Mississippi, and besides a casino, they also have, it turns out, the government lands, they don't have as much permitting and things, so every renewable and alternative energy company wants to come talk to the folks there to try to get them, because it's easier to get that going on those lands than it would for traditional other public lands. So we looked at wood chips, and we also looked at chicken litter for that, but you kind of don't want a chicken litter storage unit right next to a casino. You know, there's some issues there, so that wasn't going over very well. But we also look at wood chips. We have a lot of wood in Mississippi, and an opportunity to do that. We looked at photovoltaics at a water park, and I'll talk a little more about that. And then a project I spent a lot of time on was biomass in farms, where you wash the manure out into this tank, and these little organisms eat that and then make gas, which you can then burn in a biogas type of thing. So that was really interesting. As an electrical engineer, I never thought I'd have hip boots on walking through cow manure as one of the research projects, but it helped me understand a little bit from a small distributed generator, what are some of the opportunities and challenges. Also worked on some biomass. Mississippi State has a center that's looking into some biomass related issues. And then more recently looking at combined CHP, which can mean different things to different people, either combined heating and power or cooling heating and power, depending on who you're talking about. That's where we actually gain a lot of efficiencies, is when we combine heating and electricity together. And especially in places, not necessarily in Mississippi as much, but in Kansas, where you have a heavier heating load, or even further north, where you have a lot more heating load in addition to your electrical load. And then when I was in the UK, I got to work on a little project on a home solar and looking at storage. So that's a little bit about myself, just so you know kind of where I'm coming from and what my background. But what I wanted to talk about is changing the conversation related to in the United States. Because after 4 months of living in the UK and Wales, I really saw that we approach things very differently in the US than they do in the UK. And I want to talk a little bit about that. And so I'm going to talk a little bit about some personal experience, professionals, some national challenges and opportunities, local challenges, and some technical challenges. And talk a little electrical engineering, not too much. This late in the day, I don't want to put you to sleep, although you all did have sugar and caffeine boost out there, so I may be okay for another 15 minutes. But this is my little, I thought we needed CAT. So this is instead of see no evil, hear no evil, and speak no evil, it's don't worry about energy use, you want to hear about energy use and sustainability and don't speak anything about it. So sometimes in our community, in our country, we don't worry about it because we have plenty of energy and we just won't worry about it. Although I would say, and this came up in a discussion today, my children, I have an 18-year-old and 14-year-old, are probably much more cognizant of these issues than I am. And so I think our children are actually going to be the ones that are pushing us to do more, even as we try to do more. So personal experience. One thing is you take an engineer and take them to the UK, and like a lot of stereotypical engineers, I want the technical solution and let's not worry about the social and all political and all that stuff. You know, just fix the technical part and that should work, right? I mean, the equations work out, so why can't we use that solution? So one of the things I really saw was the difference in recycling versus trash. And in my flat that I had, we had a trash can that was this high that was for recycling, and the trash can for trash was that high, which is kind of different than what I have at my house in the U.S. As far as they could recycle everything. It almost, when you bought anything, everything was recyclable. I mean, everything was there. And that was not something that, I mean, we try to recycle. In Mississippi, we don't have a very active program. You have to carry stuff. We don't have curbside. So it's a lot more effort. But this, you put it all in one bag. You didn't even have to separate it. And then you put it in a recyclable dumpster, and someone else took care of it. So it made it very easy for me as a consumer to help recycle and work on that. Public transportation. I didn't have a car. I was able to walk or ride public transportation, a bus to work every day. It was wonderful. It was really nice, and something that you could get around even as a visitor for an extended amount of time. I could take trains to get to London and lots of other things. So there are lots of public transportation and options that really, in the U.S., in some cities we have, but really Cardiff is not that big a city compared to if we took a lot of the same U.S.-sized cities, wouldn't probably have that extensive public transportation. Packaging. I brought my little cheat sheet here. How many of us have these bags with us? Probably in this group a higher percentage than the average. But in the UK, everyone had them with them all the time. And you went in, you actually paid for your plastic bags. And in Wales, they're actually outlined plastic bags. So you always had your own bags, you brought them in there, and it was second nature to them. I had to remember to bring my bags because I was an American and learning. So just the whole way things were packaged to minimize the waste and things like that. The other thing you learn is when you're carrying your groceries, you have a much different perspective than when you're throwing them in the back of your car. You know, that can of tomato sauce or spaghetti sauce becomes tomatoes and other things that are much lighter that you use. But the other thing I found in the UK is it was cool to be green. And I think that was a neat experience to see that was one of the things that there were conversations about it, there was a lot more discussion, public awareness. And I think as we go, sometimes when we talk about some of these issues, there's a big resistance, but I found in the UK it was more of a cool thing to do. Some professional experiences that were interesting was just the conservation efforts. We talked a little bit about that. The building I worked in had motion sensors, so all the hall lights were on motion sensors. And remember, when you're talking about the UK, you're talking about fairly far north, so in December, the lights, it's dark fairly early. But around holidays, I would walk in the halls and they would be dark, but then they would turn on. And so they automatically turn off and turn on. We also, in my house, we had one of those water heaters. It's the instantaneous water heaters, so there's no tank, and it just heats water when you need it. And so there wasn't some waste in that area. The other thing is, in every paper that was presented on power systems, there was talk about the carbon footprint. In the U.S., we talk about that a little bit at conferences I go to, but but in every single paper when I went to a conference in Italy, they talked about that. And so it was just it was a subtle thing, but very interesting to see. There's a lot of creative solutions and implementations, and I think one of the big things that I think is different, and it's a small thing, but it's not if all this is going to happen, but it's when. And so they know some of this is going to happen, and so how do we come up with solutions? We have to find a solution because we're going to have to do this. Not, well, if we can make this economically viable, then we're going to do it. But it's how do we make this economically viable? And so this right here, and it's not a great picture, but there's actually talk about building a barrage, which is really between Wales and England is a channel, and actually if they put basically a dam here, they can produce between 5 and 10% of the power needed in the UK. Because this is the second largest change of tide in the world. And so the tide comes in and the tide goes out. Now, from a technical standpoint, it's very viable. The problem is you've got sedimentary, you've got animals and the environment, and so it really shows a lot about some of the balancing we have to do, that sometimes the technical solutions have other issues, and even though the engineers can go build it, it doesn't mean it's going to happen. And that's one of the things that we have to, as engineers, have to understand the political and social implications of our engineering designs and activities. So let's talk a little bit about some of our national challenges. One of the things, I went to a presentation and they talked about the implementation of alternative energy and how in the US, you see there's a bill that for 3 years we get incentives. So we see a 3-year increase in those, and then the incentives go away, and then it drops. And then 2 or 3 years later, there's a 3-year bill, so there's a rise, and then it drops. But if you look in Germany and some of the other countries in the EU, they're guaranteed a 10 or 15 or 20-year tax incentive. Well, we all, if we look at a 3-year risk or a 10, 15, 20-year risk and a rate of return, I mean, even an engineer who doesn't know a lot of economics knows it's a lot easier to decide to do renewables and alternative energy when I've got a 10 or 15 or 20-year return than a 3-year return, that whether or not I want to do that. Balancing the reliability, and we'll talk about that. And this is a topic we don't really talk about, but is also a big issue in solving the next generation of problems, is we have to have the next generation of power engineers. Because there are going to be new problems, and how do we solve that if we don't have those people thinking about sustainability or renewability, but they've got to be there. So this is an example. I pulled this from an EU report that was actually in 2004. It looks like I lost part of the reference there. But this shows the goal for renewables. And the EU has actually, they've all signed on for a certain percentage by 2015 and 2020. And there are penalties if you're not at that level. So there's a lot of work going on, and you can see by 2020 some of the goals related to and this is heating and cooling example. So you can use electric in there, but some of the different activities that can use, and you can see tidal in there, which is that small little bit, but there are a couple of places, and that's one of the things. The UK doesn't really have a lot of renewables, so tidal is one of its big possibilities. Now, balancing reliability and sustainability. I'm going to put my engineering hat on for a little bit as we talk to this group. The challenge is, as engineers, we just want to fix it and then move on. And what we want to do is we want to make sure we understand the political and social. But I would also challenge those of you who are working with engineers to think about some of the challenges we have from that side. Is reliability. You want your lights on, you want your computer on, and the public especially wants that at a reasonable cost. And so we have to balance the abilities, reliability and sustainability, because as we look at solar and wind and other cases, Right now, the technology is not there to make sure we get the expectation that you have on this end. And so we're balancing those two. And so I'd encourage the engineers to be open to some of the ideas related to sustainability. And I encourage those of you who are encouraging sustainability to also think about the engineers and put your engineer hat on for a little bit on the fact that you want it to be reliable and people to be dependable on electricity. The other big thing, and I'm a member of the IEEE Power and Energy Society Governing Board, and one of the things we're very concerned about is workforce. And are we going to have enough power engineers to solve the new problems related to sustainability? And this chart helps demonstrate the fact that the one positive thing about the economy not being good and retirement funds is people are staying longer, which is good in the power industry because we don't have enough backfill. But eventually the stock market will move up and they will decide to retire. But one of the challenges, if you look at this, the blue are the people you expect to retain. And of course, they'll get older with each age, with each year. But the red are those that can retire. And then the green are those that might move into other areas. And so if you look at this, we have a concern of an aging workforce of engineers who have a lot of experience in power engineering, who the next set of problems are going to come up, and will we have the workforce to be able to be successful and solve those problems? So one of the things we need to do is be working together to help encourage people to go into not only sustainability from environmental and policy and social sides, but also the engineering side so they understand sustainability and can help us create the solutions that we want related to sustainability. So the other thing I think is really important as we talk about this is that one size does not fit all. And when you talk about the UK, it's a relatively small island compared to the United States. And I use this example to show you the fact that the wind, this is Mississippi down here, and you can see we don't have a lot of wind. The only time we have it is during tornadoes and hurricanes, and those aren't really sustainable types of energy sources, okay? I had wind chimes, and I heard them ring when Hurricane Katrina came through and a couple other times. So obviously wind is not a solution for Mississippi. But the fortunate thing is if we look up here and we get a little closer, we're fortunate that in Kansas we have a great energy source here. And I think it seems really appropriate that the good wind is in purple. It just kind of says K-State's supposed to be helping to lead this. So what we can see here is one size doesn't fit all. So when they talk about sustainability in Kansas, and when we talk about sustainability in Mississippi, we're approaching it at different issues. And we have to realize that when we come to the table at a national way, that our solutions are going to be different than other people's. And that's okay. But we just need to realize one size does not fit all in the U.S. because we are such a diverse country related to our renewable type of resources. The other thing I wanted to talk a little bit about some of the electrical engineering issues. And what I'm going to show you, the next 3 slides show you a power curve related to a load. And basically what this is showing you is this is how much power, this is, as the day goes on, how much power a casino uses, okay? And those of you who have ever been to Las Vegas or other places, you don't know if it's day or night when you're in a casino. They don't want you to know if it's day or night. That way you're spending your money all day or night. And you can see the load doesn't really change a whole lot. Well, that makes it really easy to control. This is like having your car run on the interstate, right? You get the best fuel efficiency because you're staying at a constant level. Well, let's look at this one. This is a water park in the middle of Mississippi that's open from 10 in the morning till 6 at night. And you can see the load like this. Well, if you look at this, you can say, hey, what do you notice about from 9 in the morning till 6 at night? That's when there's a lot of sun. So this might be a case where solar might be a good way that we could use, do some supplemental electrical energy, because the load profile is such that it matches and it gives me some flexibility. Now, this is the little dairy farm that I was on, and they milk the cows twice a day, and so those are all the pumps from milking, so that's where all their load is. So it looks like a roller coaster, and that's what it would be for a generator to try to follow that. And so this is a very different question on how big should I make it? What kind of distributed generation can I use? And so one of the things that you want to think about when we talk about distributed generation resources being connected, if we're talking about how to siting where to put distributed generation and how to work with that. Support of the grid is a big issue, making sure you've got somewhere you can connect in to get the power. If you're producing more power than you're using, you got to have a way to get it connected. You've got to have an electrical highway. Location of where do you want it transported? It's got to be somewhere, if you're going to move it around, it's got to be somewhere you can transport to. The non-flexible siting is use fuel as close to the origin as possible. After Hurricane Katrina, Mississippi had a ton of wood down in our forests. But the challenge was it was not economical to move it. So what we needed was a portable generator that we could put in the forest and run the trees through. But then we needed from that generator a wire, long wire, to the electrical grid. And so that made it unfeasible. Even though we had a huge fuel source, we couldn't take advantage of that because of some of the technical issues that were there. Looking at smaller farms and businesses where you try to produce your power locally and and even sell it back, but there's some challenges related to that, and I'll talk about that. Load on site, like we saw the load for the dairy farm, and how do we figure out how much power to produce and make it economical, available fuel and technology, and also the pricing structure. I understand Kansas now has net metering, which is a very positive thing for looking at alternative energy. Is that true? Kind of?
Depends on where you live.
Okay.
What your company is.
Okay, depends. I guess the co-ops don't, but the IOUs do, right? The investor-owned utilities do? Okay.
Most meters, but like no means all meters.
Okay, so anyway, we'll talk a little bit about that. But in Mississippi, for instance, if I buy power, it costs me 5.5 cents. If I sell it back, I get 2 cents. It's very hard to find any technology that is cost-effective at 2 cents. With net metering, you basically buy and sell at 5.5 cents, so it makes it a lot easier on the economics. So what are some of the technical challenges? The sustainable energy equipment costs are still up there as far as and we're working on improving those. We talked in the research areas, how do we get solar cells and work with the wind turbines and other things. Quantifying the economic and social benefits. I think we've talked a little bit about that. How do we quantify the benefit? It costs me this amount of money, but how do I quantify the benefit? Life cycle costs. One of the issues is looking at the whole life cycle, not just where you're producing electricity, but the whole life cycle, and you can have some different activities and different thoughts related to some. The interconnection issue I've talked to. Storage is a huge issue. If we can find a way, and a cost-effective way for storage, we would be in much better shape. And then there's always the political issues that relate to the technical challenges. So some of the interconnection issues for those that are interested in a little more technical side, there are standards to help standardize this. So the same way when you plug in an appliance, it has the same, in the US versus somewhere, it has the same standard. Well, you kind of need that same thing whether you're plugging in a windmill or a solar cell or some other biomass type generator. Protection is an issue because of our system synchronization. Safety is an issue related to you and other people if you have a generator going. And then the metering. I talked a little bit about the metering aspects. It doesn't like me. So there are some benefits to the utilities, which they won't always talk about, that we need to encourage and try to quantify this to look at the issues. Decrease losses, you can delay upgrading, some different support mechanisms, you can decrease generation costs, and one of the interesting things that we wanted to look at related to Hurricane Katrina was actually using distributed generation in emergencies by islanding and providing power to small areas, where we can do that if we have a windmill and we can provide some power to an area or solar cells and some of that. And how do we do that after a tornado takes out some of your transmission grid? You can still have power locally and working on that. So one opportunity for those of you in engineering is there's a new journal that's going to come out on transactions on sustainable energy, and the IEEE Powered Energy Society is one of the co-sponsors of that. So if you're doing some work in this area from a scholarship perspective, especially if you're looking at system level activities, this is an opportunity for you to be involved and publish some of your work. And really, to kind of bring it full circle, is talk about what are our opportunities here at K-State. And I think you heard Kirk talk a little bit today about really, as a land-grant institution, it's our mission and responsibility to help look at some of these solutions and try to come up with these to provide to the state and the U.S. I think a strong engineering and agriculture activities can help with these solutions. That was one of the reasons I gave a seminar here 10 years ago as a faculty member. I was very impressed with engineering, and when the opportunity came up for Kirk to apply here, I was very excited because I knew it was a place that I could make a difference in engineering because of the great program we have here in power engineering as well as engineering as a whole. And then, you know, I think the opportunities to dialogue on public perception and public acceptance as well as the technical and policy issues. And I think we've touched that throughout today. It's not just about public perception and acceptance, but technical. All of those are important and have to work together in order for us to come up with a solution. And that's where this dialogue and the interactions and some of the outcomes of this group and the task force activities will help us start that dialogue so we can come up with those solutions. And by having a diverse team attack it from many different angles, we will come up with a better and better solution and be able to optimize for some of the problems we have. So I really appreciate this opportunity to share and talk to you a little bit about some of my impressions and my background. And I'll open it up for any questions. And there's my email if you want to contact me and talk more about some of these topics. Thank you very much.
I think we probably have time for one or two questions before moving on to Gary Schubert.
Would you comment on wind energy versus solar energy for Kansas? Do you see them equally bright as their future, or do you see one as having a greater potential for us to pursue?
I think at least most of the proposals that I know that are being written right now are mostly in the wind energy area. And I think with Ruth and Anil and others who have been doing some wind-related work, we can build on some of those strengths, the Wind Application Center, and some of that, we can build on that. So I would say that would be our first area that we've got some momentum. I think really we need a diverse, kind of like our retirement, we need a diverse portfolio to help us work into different areas and look at what are some of the different solutions we can have. So I think solar has a lot of opportunities related to passive solar and some other cases that may be able to, they're a little more complex solutions. So I think wind is where our strength is, and I read somewhere we're the third windiest state in the country. So, you know, obviously we've got a fuel out there. And so I think that's where we need to, but I think we want to diversify and look at all different solutions so we can do in different areas. Because like you saw on that map of Kansas, everything, we're not created equal in the state of Kansas even, where there are resources for wind.
One other?
Do you see movements at all towards more distributed and less grid intensive within that? Maybe Love wrote recently about the grid was set up because of sort of faulty generation, and now the grid is starting to be where we have problems. And it seems like that is a sustainable idea that we regionalize the energy generation needs. And it's a hard thing to get to because we have so much invested in infrastructure now. I wonder if you thought about that issue and how that might happen.
I think we're going to have, for the reliability we need, and because we're not able to build the transmission lines we need, they're taking 10 years to do some of those, that we're going to see a more distributed power system. And really, when you talk about the smart grid, it's the ability to be able to go together when you can, but also function in separate units when you can, when it's economically or an emergency case. So I think we're going to see more distributed, partially for reliability, and partially because we're just not going to be able to build those transmission lines, because you've got to get, it goes across 3 states, you've got to get 3 public utility commissions to agree on it, and one can throw a wrench in that. And so it's very complex once you get interstate and all that. So I think we're going to see a more distributed, and we're getting to where it's more and more cost effective. The reason we had the grid was just the scale, economy of scale, and now we're getting to the point that we've got more resources that can be distributed, and that makes it more reliable because we can break up into a disconnected grid if we need to. All right, thank you. I'll be on the panel later if there are other questions.
All right, thanks very much. Thank you.